So I guess first off, many thanks for joining. It's a pleasure to have you here today. I really wanted to start off with a brief overview of who we are at Royal Haskoning. So we are a global engineering consultancy with over 140 years experience. We're present in 150 countries and we have over 6,000 employees. So Royal Haskoning is a team of sustainability consultants, engineers and designers, and we're all passionate about making a difference. We use our expertise to help clients improve their businesses and communities, and we're committed to creating a sustainable future. Our big, hairy, ambitious goal, our big BHAG, is to enhance the lives of 1 billion people worldwide. Our company tagline, in fact, is enhancing society together. It's something that we use all the time, and it's something that we really try to embed into the projects that we work on. So in terms of sustainability, this is something that is close to our collective hearts. Everything that we do at Royal HaskoningDHV is focused towards making a positive impact on society and the environment. And we've zeroed in on 5 key purpose themes where we can really make a difference. And we're actually measured on these. So these themes are woven into everything that we do, from our team, our clients, to our operations and projects. And by mapping out the impact of a project, product or service, or even our own operations in a chart from negative to positive, we can really push ourselves and our clients towards more positive outcomes. So these themes are super important to us for our impact towards sustainability, and we feel like we're in a unique position to be able to make a difference. So what are the different themes that we measure ourselves on? So first and foremost, probably the most obvious is climate change, human activities of climate change, which is already affecting billions of lives. We need to significantly reduce emissions and adapt to changes while building resilience for the future. Biodiversity and natural systems. So biodiversity is really the backbone of the air we breathe, the water we drink, and the food we eat. And it's crucial for the systems that we rely on. And human activities are affecting species and ecosystems in ways that could harm our future well-being. Resources and circularity. So we're extracting natural resources at an unsustainable rate and often using them wastefully. So moving towards a circular economy where resources are reused and recycled is a big challenge, but essential for a sustainable future. Social value and equality. So our projects have the potential to bring about positive change for communities and society as a whole. So we actively promote diversity and inclusion, challenge inequality, and work closely with clients, stakeholders, and communities. And finally, safety and well-being. So safe environments are a fundamental right, and we strive to ensure this through our projects and practices. We embed safety in design, operation, and culture, and prioritize mental well-being alongside physical health and safety. And we're excited about the impact that we can have as a business and are committed to making a real difference. So we're here today to talk about sustainability, and I guess I kind of started this process by recapping to myself what defines sustainability. And the United Nations, I think, have got a particularly good way of defining it as meeting the needs of the present without compromising the ability of the future generations to meet their own needs, which I think wraps it up nicely. So in terms of industry, what are the key sustainability drivers in industry? These can be broken down into 3 key areas. So there's social responsibility, corporate goals and stakeholder expectations. Sustainability is increasingly becoming a part a core component of corporate goals and stakeholder expectations. Companies are recognizing the importance of social responsibility and are integrating sustainable practices into their business strategies. So this shift is driven by the growing awareness of environmental and social issues among consumers, investors, and employees. And by adopting sustainable practices, companies can enhance their reputation, build trust with stakeholders, and meet expectations of socially conscious consumers. So, for example, many companies are setting ambitious targets to reduce their carbon footprint, improve labour conditions, and support community development initiatives. So these efforts not only contribute to a better world, but also align with the values of their stakeholders, driving long-term success. Then there's environmental impacts such as emissions, waste, and resource consumption. For the environment, the environmental impact of industrial activities is a major concern, and sustainability is driving significant change in how industries operate. So companies are increasingly focused on reducing emissions, minimizing waste, and optimizing resource consumption to lessen their environmental footprint. So this involves adopting cleaner technologies, improving energy efficiency, and implementing waste reduction strategies. So, for instance, many companies are investing in renewable energy sources such as solar and wind to reduce their reliance on fossil fuels. Additionally, industries are implementing circular economy principles where waste and materials are recycled and reused, reducing the need for virgin materials and minimizing waste generation. These efforts not only help to protect the environment, but also ensure compliance with stringent environmental regulations. And finally, there's the economic benefit. So cost savings and efficiency. So sustainability can absolutely go hand in hand with industry. Sustainability is not only about protecting the environment and fulfilling social responsibilities, it also offers significant cost benefits. So by adopting sustainable practices, companies can achieve cost savings, improve efficiency, and ensure compliance with regulations. So waste reduction initiatives can lead to cost saving by minimizing disposal costs and maximizing resource utilization. Moreover, companies that prioritize sustainability are better positioned to comply with environmental regulations, avoiding potential fines and legal issues. So in addition to these direct economic benefits, sustainability can also enhance a company's competitiveness by attracting environmentally conscious customers, employees, and investors, and ultimately driving long-term profitability. Okay, so let's get a little bit more specific and focus on Witness predictive simulation. So with Twin Witness, we can help you create better performing operational and strategic processes. We can help provide decision intelligence and guide you on what key changes need to be implemented to achieve a desired goal. Some of you may not know what simulation is. So what is simulation? Simulation is a virtual representation of your world. It gives you the ability to understand the impact of making changes to your business within a virtual environment. And you can understand how different decisions can have a significant impact on your business in a risk-free environment. And why is that important? Because processes in the real world are variable, they're complex, they're interconnected, and there's no other way to achieve that kind of understanding without a predictive simulation tool. Okay, so in terms of simulation, how can simulation help companies address these key drivers in sustainability? So first up is resource optimization. So discrete event simulation can be used to model and analyze the allocation and utilization of resources within a system. So by simulating different scenarios, It's possible to identify bottlenecks, optimize resource allocation, improve overall efficiency. So, for example, in a manufacturing plant, simulation can help determine the optimal number of machines and workers needed to meet production targets while minimizing idle time and reducing costs. Simulation can help reduce waste. So Twin Witness can help identify areas where waste is generated and suggest ways to reduce it. So by simulating different processes and workflows, it's possible to pinpoint inefficiencies and implement changes that lead to better resource utilization. So for instance, in a supply chain, a simulation can be used to optimize inventory levels, reduce lead times, and minimize waste due to overproduction or stockouts. So with the cost of energy on the rise, energy efficiency has become increasingly important. Tracking and managing energy usage to reduce consumption and costs can be achieved using witness simulation. So by modeling energy consumption patterns and simulating different energy saving measures, it's possible to identify the most effective strategy for reducing energy usage. So for example, again, in automotive paint line, witness can help determine the optimal scheduling of startup or operating times and downtimes to minimize energy consumption while maintaining quality levels. For example, this operating model could be lined up to make use of cheaper energy cost periods. Then there's emissions reduction. So monitoring and controlling emissions to meet regulatory standards and reduce carbon footprint can be facilitated by discrete event simulation. Simulating different emission control strategies and their impact on the environment, it's possible to identify the most effective measures for reducing emissions. So for instance, in a transportation system, simulation can help optimize routing and scheduling to minimize fuel consumption and emissions. And what about transportation optimization? So reducing logistics costs can be achieved by modeling transportation networks and simulating different schedules. It's possible then to identify the most efficient routes and schedules that minimize fuel consumption and emissions. So for example, in a delivery service, simulation can help determine the optimal delivery routes and schedules to reduce travel time and fuel usage. Or witness can be used to model your supply chain network design. So looking at where to locate your local distribution centers to minimize journey times and hence fuel costs. Then we can look at water stewardship. So as a Dutch-based company, water management is particularly close to our hearts, and it forms a large part of the projects that we work on. As water becomes a scarce commodity, this is becoming an area of increasing importance, not only for water companies, but for industry where water consumption is high. So minimizing water consumption and preventing water waste can be addressed by modeling water usage patterns and simulating different water saving measures. It's then possible to identify the most effective strategies for reducing water consumption. So in a recent project for a multinational drinks company, we helped them reduce their water consumption and wastewater output, resulting in significant savings for their operations. And finally, renewable energy. So alternative power and storage solutions can be explored through simulation by modeling integration of renewable energy sources and simulating different storage and distribution scenarios. It's possible to identify the most effective strategies for maximizing the use of renewable energy. So for example, in the power grid, simulation can help determine the optimal mix of renewable energy sources and storage solutions to help ensure a reliable and sustainable energy supply. And now I'd like to hand over to my colleague, Steve Jones, who introduced himself earlier. He's our global leading professional for simulation He's going to talk us through some recent examples of applying simulation in the area of sustainability.
Yeah, thanks,
Thanks,
Duncan.
Steve.
I'm gonna try and show you some ways we've used simulation to address those things on the screen there. So I haven't got much time per case study, so any questions, please drop them in the chat, and we'll try and hit on all those different areas. So the first one here is in some ways fairly typical industrial process, complex bill of materials coming together in an assembly, and in some ways very different. It's a very large scale because what's being produced here is modules for modular home construction on site. We're involved in this project, really looking at it from the efficiency perspective, planning the most efficient use of the resources available. So some work was going on to look at CNC machines and the efficient use of material, but in changing the way that those machines work and the way that the process operates meant there were changes to WIP, to the amount of stored material and the transport material handling around the very large site. So simulation was used to prove that any changes to those processes could be implemented and wouldn't have a bad effect on the throughput of the factory. We worked with industrial partners on this to understand the impact of that efficiency gain, and look at efficiency of resources of people, skilled trades moving between all these modules, as well as the material use. So it really is a great example of how simulation can be used for efficiency, and I think really has a social value here. These are sustainable homes being built for affordable housing. And an example of how concepts like lean can come into industry and be proven through the use of simulation to address all the different types of waste. Okay, next one, please. Okay, so a common reason for looking into simulation as a topic in industry is looking at energy consumption. So the example on the left there is looking at steel, the smelting plant, where obviously there are high energy components to that process, and there are, through process changes, there is the ability to reduce the total energy required, but also to look at peak energy usage through time. So that work in that project is built on work published in the journal in the bottom right there. There's several papers using our software Witness published in that journal, showing how you can use discrete event simulation to model that energy consumption and play what if scenarios through to understand how to smooth out that peak and look at ways to meet that need with potentially with renewables, and potentially lowering the total energy usage as well. I think this approach has also been used in the compressed air and steam use in industry. So I think that's really important to say that simulation can be very flexible to use the same approach to different areas like that, but really could be applied to anywhere with high amounts of heating or cooling, high energy usage machines like pulping in the paper industry, or high energy use in, for example, battery manufacturing. Okay, next one, please. So Duncan talked a little bit about logistics. This was a really interesting one. We're looking at the logistics of CO2 capture. Now, this is a technology is fairly immature, and companies are looking really to understand how that could work with the supply chain of capturing CO2, liquefying it to transport it, and storing it underground. Interestingly, in the real world, they use LNG technology, that's liquefied natural gas, to liquefy the CO2. And we are also using simulation of that same industry, which applies in a very similar way here. Again, transferable from one industry to another. We can understand the logistics and the supply chain of this product that is being captured from an industrial process. In particular, the questions here really around storage, number of vessels or tankers needed to transport the goods, and the business case for investing in a new port to operate this supply chain. Next one, please. Okay, so this one is looking at renewables. We've been involved in the renewables industry for a little while. We're looking here at floating offshore wind. So we are involved in particularly in the logistics of that industry. Just starting a new project actually in this area around the Scottish waters. But I think it's important to say where this project was looking at the renewables industry, I think this could be applied very well to the use of renewables and the transformation of a business to using renewables, and a combination of this transformation planning that we've done in this work, along with the energy consumption and demand, and matching the supply and demand with that other case study. A really good bit of work here. It's interesting that we're not just looking at the risk to the supply chain here of installing this new wind farm, we're also looking at climate change and its effect on the risk in this supply chain, which again applies to many businesses, that we need to consider different future scenarios of the climate to understand the probability of disruption. Okay, next one, please. So Duncan talked a little bit about the water industry and the fact that HaskoningDHV, being a Dutch company, has a strong reputation in water. We actually have a team involved in looking at water in industry. The example on screen is actually a municipal wastewater treatment plant, but we do quite a bit of work with industry partners who have their own wastewater treatment. But really, any business that uses water to as part of their processes, particularly in food and drink, as Duncan mentioned, in the drinks industry, that's soft drinks and harder drinks, and also things like chocolate manufacturing. All of these processes that use water in as an ingredient, but also for flushing systems, which is pretty common process, leads to a need to think about careful stewardship of water resources, the rivers and lakes around our industry. And simulation can be used to predict the level of water usage, the need, the storage of water. The example on screen is actually really interesting as well, because it's a predictive simulation as a component of a digital twin, looking at live levels in a plant and using the simulation to predict forward to understand what would happen if a change was made. So yeah, just a really good example of how simulation factors into a number of other analytical techniques like digital twins, machine learning and AI, that can all come together to help you operate your process or make decisions about your process. So most of the things we've been talking about are strategic decisions, but it can also move into an operational world. Okay, final one, please. So I think we had as the final bullet point on Duncan's slide looking at circular economy. So the circular economy, for those of you not aware, is a linear economy would be one where we produce goods, send them out to customers. When they're worn out, we throw them away. And sometimes this circular economy idea is conflated with recycling. Yes, it's okay. We'll recycle the goods when they're at their end of life. But a circular economy looks to plan for the return of the products to be reused, repaired, and recycled if necessary, to enable much better use of materials. So this project is one example. Phone repair in the UK, looking at the service centre that would take in batches of different phone products, a complex list of past generations of phones coming in, being reworked, repaired with different error codes, complex rework loops and testing. that simulation enabled the customer to win a contract to supply this service center and to enable these valuable goods not to go into landfill. Really interesting in this case. One anecdote from it is they use in one of the tests they discharge the batteries of the phones, and rather than losing the energy from that process, they take the energy from that to charge up the next batch of phones. But obviously that means the processes need to be aligned to the batches. The timing of those is important, and simulation helped to smooth that process out to make sure that that could work and the energy loss would be minimized. Really important, especially in this case where batch processing in a linear production environment, you get to decide your batch sizes. Here, the reverse logistics of getting a phone back to a customer and the lead time to do that were really important. So a really good example of the circular economy and planning for reuse of materials. So yeah, just to summarize through all of those, so we've looked at efficiency, we've looked at energy consumption, but also supply, potentially through renewables. We've looked at logistics and the energy use in that. I didn't touch on emissions. We are also looking at a few projects at the moment around emissions, around logistics. We've looked at water use in industry and the circular economy. So hopefully you can see there's a range of different ways simulation can be applied to sustainability as a broader topic, but really any change or transformation in your business, any business case or investment that needs to consider complexity and risk, as Duncan said, I think you can use simulation in those cases to help you better understand the impact of a decision you might make before you make it in a risk-free environment, to hopefully make industry more sustainable. So back to you, Duncan.
Thanks, Steve. That was great. Really interesting. So yeah, really quickly in summary, so sustainability in industry is crucial for ensuring long-term economic growth by reducing costs, increasing efficiency, and fostering innovation. Embracing sustainable practices helps industries mitigate risks, comply with regulation, and enhance their reputation, ultimately leading to a competitive advantage. Sustainable industrial development is essential for preserving natural resources and protecting the environment for our future generations. And as Steve said, witness simulation can help you address your corporate sustainability goals, and hopefully we've demonstrated today some of the areas where you can apply simulation in those areas of sustainability. So thank you all for attending. It's been a pleasure. If you have any questions, please put them in the chat or reach out to us. We're both on LinkedIn. So yeah, happy to take any questions from the audience.
We don't seem to have any coming in at the moment, but like Duncan said, if you do have any to follow up, please go directly to them via LinkedIn and they'll be happy to answer those for you instead.
Thank you. This has been excellent.
Thank you.
Thank you.
Can I ask a question instead of writing in the chat? So yeah, thank you for the presentation. It was very interesting. So my question is about sustainability reporting. Is that an area you have looked into, given that you can capture significant amount of information during the simulation and then the monitoring? I guess there is an opportunity to also fit into the reporting aspect, especially with with the new compulsory standards in Europe in particular. So I guess there is an opportunity there to also connect the system and the collecting and monitoring of information with actually supplying the reporting aspect, I guess.
Yeah, I think that's... Sorry, go ahead, Duncan.
Yeah, no, it's a great question, and thank you. And I think that's where being part of the wider Royal Haskoning group is really where we're bringing all of that expertise together. So it's a combination of that reporting team tied up with the digital aspects and bringing that together to help companies move through that reporting process.
Yeah, so we've got a number of teams that may be worth mentioning. So there's some teams across HDHV who look at sustainability reporting and KPIs. I do think we could align the outputs of the simulations from our work with their reporting to help understand the road to a transition to a more sustainable business. We've also got teams that look at climate resilience and climate risk, and the data from those can be used to drive the risk profiles, the probability in the simulations. We've got teams looking at, for example, water and industry, that look at specific aspects of sustainability. And yeah, all of those could come together given your specific need, I think. So yeah, be interesting to take it further. See, I think in quite a lot of our projects we're guided by our customers' method of reporting, but as that becomes standardized, that's something we could definitely look to build into our software.
Okay, thank you for that.
Any more questions? Are there any more questions in the chat?
Yeah.
Abby?
One has just come in. Where is the mechanics of the digital twin interface documented? Is this only SQL or do you use Python?
I'll take that one.
I'm going to leave that to Steve.
Very happy with the technical question. Yeah, thanks, Neil. So in the case of that digital twin example I showed, the interaction was an Azure digital twin environment. So this is in the cloud. We're running a witness simulation also in the cloud on our Witness IO software. The data was being passed via files and databases between the two. So typically, I think the digital twins outputting JSON and the simulations inputting CSV. If you're interested further in the Witness API or the Experimenter API or the ability to run on Witness IO, I'm more than happy to go through the details of that with you another time, if that's useful.
Sure.
Yeah.
Very good.
Yes, but yes, we do use Python to connect to the API to make generic models. Yeah.
Okay. Cool.
It also happens to be a personal hobby of Steve's API, so I'm sure he'd talk to you at length on that subject. So. Any more in the chat?
No, nothing else in the chat now. No.
Okay. Well, I think we'll leave it there for now. Thank you again for attending, and thank you for the questions. And yeah, hopefully speak to you soon.
Thanks, everyone.
Thanks,
Thank
everyone.
you.